So in the last video we talked about introduced the cross product between two vectors. So in this video we're going to talk about how if you have two vectors that are in Cartesian form, how you can calculate the cross product between those two vectors. So if we have a cross product between vector A and vector B, we can write each vector in its Cartesian form, and then we can then multiply each component of the vector across, and do the same for all the other components. And we do that, what we end up getting is we get these 9 individual values, and where we have a scalar coefficient, right, and then we have a vector cross product between our unit vectors I, j, and k. So we're going to take the cross products of each of these individual of these unit vectors and see what they're going to be equal to based off of the definition that we established in the last video. So for example, if we start with I cross I and figuring out what's the magnitude of I cross I, we're going to get the magnitude of vector I, which is 1, times times the magnitude of the other vector, which is vector 1, which is also equal to 1, and then that's going to get multiplied by the sine of the angle between those two vectors. So since the unit vector I goes along the x-axis, and so with the other unit vector I, the angle between them would be equal to 0 degrees. So that sine of 0 degrees is equal to 0. Alright, so because of that, we can say that this term would become 0. Alright, and in a similar fashion, j cross j would also be equal to k cross k. Those terms will also be equal to 0. So we can get rid of all of these terms along the diagonal. Then our other terms, like I cross j, if we figure out the magnitude of that cross product would be equal to 1 times 1, because both the magnitudes of I and j are both equal to 1, and then the sine of the angle between them would be equal to 90 degrees. Alright, and then so then sine of 90 degrees is also equal to 1. Alright, so if we look at that, the magnitude of j cross k is also going to be equal to the magnitude of k cross I. Those will all be equal to positive 1. And then the final step here is would be for cross products like I cross k. Both of these will have a magnitude of 1, and then it would be multiplied by sine of negative 90 degrees. So the sine of negative 90 degrees is equal to negative 1. Alright, and then this is going to be very similar to j, unit vector j cross I is going to be the magnitude of that cross product times the is going to be equal to the same as k cross j. These will all equal negative 1. Right. So if we plug in, so the last thing here is we know that for any cross product, we know that it'll be equal to it'll be equal to the product of the two magnitudes of the two vectors times the sine of theta times a unit vector that is perpendicular to both A and vector A and vector B. So in our case, we only have three unit vectors. We have unit vector I, you have unit vector J, and we have unit vector K. Okay. So if we take the cross product of unit vector I with unit vector K, the only vector that is perpendicular to both I and J would be unit vector K. In a similar fashion, if we took the cross product of unit vector J and unit vector K, you would get unit vector I. So for each of these terms, we have to add the unit vector that is at a 90-degree angle relative to them. So we can use this circle here to determine what is going to be our unit vector for the cross product between any two vectors. So if you go counterclockwise around this circle, it'll be a positive. You'll get a positive number. If you go clockwise around the circle, you have to add a negative sign in front of your unit vector. So for example, where we have I cross J here, I cross J equals positive K. While if we looked at I cross K, I cross K is going to be equal to negative J. All right. Now, if we look at the solution to all of our cross product equations, what we'll notice is that the ax times bz function is going to have a negative sign in front of it based off of this formula, while the I cross j will have the ax by scalar number will have a positive number in front of it, and it'll be multiplied by k. All right. So for the remaining 6 terms, they will also fill up the rest of this matrix, and this is our formula to get our cross product between two vectors A and B for a Cartesian vector. This formula is a little bit tedious, so you can rewrite it using a determinant of a 3 by 3 matrix. So if we had two vectors A and B, we want to find the cross product between those two. What we can do is we can rewrite them like this, where we have the top row of our 3 by 3 matrix will be the unit vectors I, J, and K. The second row will be our our unit vector, our vector A. So it'll be the x component, the y component, and the z component of vector A. And the last row will be the x component of the y component and the z component of vector B. And then you'll have I and j together. So once you have written this all down, the next step is you're going to copy the first 2 rows of the first 2 columns of your matrix. So you'll copy the first column, then you'll copy the second column. All right, and then once you have this, what you're going to do is you're going to take the diagonals from the top left corner to the bottom right, and each of your diagonals will have 3 terms in it that you're going to multiply together. So if you do that, what you're going to end up getting is A cross B is going to be equal to So our first diagonal will be equal to AY times BZ, and that's going to get multiplied by the unit vector I. Alright, and then if you do their second diagonal, we'll get multiplied by AZ times B of X, and that's going to get multiplied by the unit vector J, so write A of Z times B of X. Alright, and then the K, the last diagonal from top left to the bottom right, will get multiplied by AX times BY. Alright, now, the final, so then to get the other terms in our equation, we're going to use the second set of diagonals. They'll go from the top right of our determinant to the bottom left. So our first diagonal is the unit vector k multiplied by ay and bz. So for all the green diagonals, you have to multiply by a -1. Alright, so we'll get, for the unit vector k, we'll get minus ay times bx. Alright, for I, we'll get minus az times by, and then for j, we'll get a of x minus times bz. So we get minus ax times bz. Alright, so that's a much simpler way to remember the same formula, 4.4, without having to remember all the 6 terms of that equation and which terms are positive and negative. Alright, so that concludes this video on how to take the cross product between any two Cartesian vectors.